a war inside my head. Sometimes I wish that I was dead. I'm broken. So I called this therapist, and she said, girl, you can't be fixed, just take this.
Here in this last section of the chapter, we are going to take a look at the new prospect of human evolution, which is related with the recently emerging life science techniques called gene editing. So, past history of evolution, in particular through the forms of fossil record, shows that humans, modern day humans, got the result of evolution through several different related, more ancient forms of humans. And now what we are saying is that is the present day human is not the ultimate end of the evolution, but it may be able to evolve into quite revolutionary new form. Maybe this is too much, but is the main idea of this section. The driving force of this new prospects of human evolution is these two issues, aging and death. Those two most events that every human doesn't want to face, but inevitably has to. So this aging and death we don't want to experience at all, to most of us at least. But then, surprisingly, for what reason, that renowned Time magazine, in their one of the earlier issue in the past several years ago, I think, by the year of 2045, instead of all this human race, after ruining all those Earth's environment and collapse, and then got wiped out of the sight, but may be able to achieve these two goals of the status of being free from worrying about getting old, and also worrying about having to die. So can be exempt from senescence and then death by this time, which is not much far away from now, 2045. I may not be able to be around by then, but definitely all of you will be alive then, and then actually check whether this proclamation is true or not. So yeah, this is that particular cover issue. They claimed that immortality can be achieved by the year 2045. Okay, through what? Innovation, technical breakthrough, which will result in more growth. But here, traditionally it has been that way. Why do we invest in technical development, progress, and scientific achievement? It's because technical innovation can bring about the economic growth. And then with that economic growth, now we can enjoy more resources and better living condition, like improved sanitation. Then as a consequence, with plenty of stuff to eat and better medical conditions, then this human lifespan, we can live much longer. It has been that way in the past. Proof in case, this our modern human is called, the scientific name, as we all know by now, is a Homo sapiens. This particular race species, it's been estimated to emerge on Earth only about 200,000 years ago. It's not that far too long ago. At that point, it's been estimated that the human life expectancy has been only 20 years. Uh, when we talk about the average human life expectancy, that doesn't mean every living human, by birth, you will only get to live the 20 years, and then you will die. No, that is not the things. But it's take the average. Maybe at the time some individual might have lived like up to 60 years old. But the reason why such a short life expectancy on average was because majority of them died at the very early age, like at it's their infancy or at their early stage of development, because of lack of food, malnutrition, or diseases, such stuff like that. Yes, so like 20 years average lifespan has been the norm until very recently. Actually, that 20 years human life expectancy has not changed much ever since then, until actually the time only about 100 years ago, when, as a result of industrial revolution, so huge economic expansion, and then accumulation of wealth, and as I've explained, so that they can take care of this, the life. So then now, all of a sudden, the life expectancy also followed the increased. So if you actually take this data in the Western, the Caucasians and the Europeans and America, maybe the Western life expectancy plotted against this GDP per capita shows that actually, so this is the economic growth, GDP, and this is life expectancy, and this is the time. So actually, the time when we saw the drastic, the economic growth, as well as this increase in human life expectancy, was around the dawn of the 20th century, actually. And then we can imagine what was the cause of this quick, sharp increase in. And so if that was the case, maybe this technology and economic growth and human life expectancy can repeat, this trend may be able to repeat itself due to the outlook of the two emerging technology breakthrough. So these two technology breakthrough are the ones that now here I'm going to talk about. So these two techniques may be able to accelerate this already steep increase the rate of human life expectancy increase, this longevity issue, with the healthy lifestyle too. One is genome sequencing, which has been already established, and like the other one is something more recently developed technique that, as I mentioned, is a genome editing techniques. So first, let's talk about this genome sequencing technology issue. As I have briefly defined the genome in the previous session of the lecture, this is an organisms or an individuals that belong to that species. The complete set of DNA, including all of its genes. So everything in your DNAs. So the genome project means which was completed during the 10-year span. Actually, it was officially completed in the year 2003. Was at the time very ambitious attempt to map the entire human genome, which consists of 3 billion nucleotide pairs. Here, if you're not familiar with, well, most of you will not. Nucleotide. This is an individual piece with which that DNA is a long chain of thread-like polymer, and this long chain of DNA is actually individual, assembled by individual components. That each individual component is called chemically called nucleotide, and there are 4 different kinds of four kinds of nucleotide. So this is a random assembly of 4 different kinds of nucleotide to make up 3. So 3 billion nucleotide will make up entire long thread of human DNA is what it says. And what do you mean by mapping? It's like just for the first time you are opening a new book and try to read from the first page to the last. So you never know the order. We call it the sequence of the entire your genome DNA sequence. If you do not know the entire human genome sequence, DNA sequence, then actually you have very little idea about where in your whole entire genome, which was organized in different chromosomes, in what particular location, what particular gene of interest is present, etc. You have no idea, and what exactly the composition of the gene, because especially if you consider in each different individual their particular gene's DNA sequence can be slightly different. If you observe, then that remain in the total black box until the completion of the human genome project. And so you are start reading one by one. Okay, here at this position, this particular type of nucleotide is present, and what's next? And that's basically what's all about the human genome project, and we call that as a mapping. Okay, so mapping includes sequencing, finding out the actual order of the DNA sequence in the whole entire chromosomes of human cell. So the sequencing of the entire genome, and once you accomplish that, then you can start identifying the locations of all the genes. As we will look at in the chapter 4, actually in our chromosomes, not every places of our chromosomes are occupied, packed with the genes. It's like only here and there. Some locations, some particular part is occupied by the gene, and some others are not at all along the chromosomes. So identifying in which location or specific gene is there is also a very important issue. So actually this was a $3 billion project in US dollars, funded by US taxpayer, and then led by 2 government organization. One is NIH, National Institute of Health, and the other one is also Department of Energy. U.S. Has this particular government department, and so this technical diagram you don't really have to pay any too much attention. But the reason why it took 10 years and it was such an expensive project, a $3 billion project, probably a huge chunk of them was like actually the salary on those staff, I guess. It's because DNA is such a long 3 billion nuclear tied long polymer, and you cannot, there's no way you can actually read this from the start to the end with the intact DNA. So you have to make first the smaller fragment, DNA fragment, and then store each different fragment. That involves this procedure. You have to clone each different fragment into the vectors and then maintain them, and then later you just take each one out and identify the DNA sequence. And then now probably one of the most daunting tasks is now the order, determining the order, assemble this so-called it's a contiguous. This fragment is it's not really easy job. It's extremely complicated and difficult job. That's why it's been taking so long, even though that project has been divided by many different laboratories in the United States as well as Europe, and even some laboratories in Japan. Okay. However, some after about 7 years has passed of this human genome project, and then the progress was not really satisfactory. But then one very strange person, or it's not really stranger at all, that particular gentleman was like a kind of a well-known entrepreneur, a businessman, and a scientist. So he he is a billionaire. He's still alive, and he runs a very respectable private institute, Craig Venter Institute, taken by his name. This is the gentleman, Craig Venter. He claimed that, well, I can start this human genome project on my own, individually, and then finish it within 3 years. And everyone involved, all other the scientists involved in the human genome project, had to laugh at him. What? Hey guys, that I respect your bravery, but we've been doing this for 7 years already, and then we are still struggling in accomplishing this, and then you alone start and then finish within next 3 years. Are you crazy? Or obviously you must be very stupid, and then you are even crazy, as the reactions from the other scientists. Well, but he did. He took whole new revolutionary approach of identifying the sequencing. It's called the shotgun genome sequencing. So no wonder with this, I don't have to go into too much technical detail, but all I can say, bottom line is, it's suffice to say that he took the whole new approach, and so it was possible to drastically reduce. So that means it is such a highly efficient in techniques, efficient procedure. So he was about to finish within 3 years. Now those government officials and then scientists got panicked. Why? Because if he finished first, then the other scientist, government funded the scientist project, then now he can claim the patent on this DNA, human DNA sequence. That's the last thing that all these people on Earth want to see. In other words, if all those human DNA sequences are patented, then if you imagine those days, then me, or layman like me, cannot have any access to any part of the human DNA sequence without paying any royalty. But in these days, actually, everyone can have an access to through the homepage of some of the several institutes along the entire Earth. So luckily that did not happen. That's the reason why actually the government kind of cheated, and so they began reporting the we completed this project, and then they started releasing the human genome sequence even before they actually finish this project, because of this, for fear of the monopolizing this DNA sequence by this one gentleman. So eventually everything went well, so that both parties made peace, so that both of them got recognized by the government, U.S. government. But anyway, so here the reason why I am bringing up this gentleman Craig Venter is this revolutionized technique of genome sequence. Without this, probably still perhaps we will be living still in the world of like, in order to finish reading one person's DNA sequence, probably it will take another 10 years, just like that. However, with these new techniques and then refinement, with the addition of many different improvements, now this finishing one person's reading of the entire genome is not going to take more than a month, even at this current stage. Not only did Craig Venter had this pioneering work on human DNA sequencing, but also he has created he was the first one who made the artificial cell. Although still is a bacterial prokaryotic cell, but it's been already reported there version 2 or version 3 even. So entirely artificial genome and then the whole new cells. So maybe 10 years down the road, we are looking at the creation of the new cells by the man-made cells. Anyway, so with that, we saw the era of the rapid progress in this DNA sequence technology. That means if you have the progress in the techniques, then obviously you will also have the cost reduction. So these days people talk about so-called this NGS, which is quite a different approach of the DNA sequencing than the original, the one used in the human genome sequencing project. This NGS stands for the next generation sequencing method. This method is difficult to understand, so I won't even touch any bit of this sequencing, the technique details. But anyway, in these days, everything like all those, whenever we deal the genome sequencing, this is the technique that is being used. So even 2 years removed from the completion date of original human genome sequencing project, actually the cost of sequencing the entire human genome has been dropped like 1/10 of from 3 billion to $300 million. That was a huge improvement. And now, unlike the original, the human genome sequencing project, which 8 or 15 different individuals all around the world, the samples were collected and pooled, so that in a way, like they were taking the average, the sequence. Actually, there was a at the time I was like an undergraduate senior when I was studying in the United States, and I used to go to lunch frequently actually with my advisor, a professor who was the PhD and a nice little nice big old gentleman from Edinburgh, Scotland. And I really had a very good times with him. And one day he asked me about this. What do you think of this human genome project? I was only the undergrad student. I had no idea what. I don't know. He was like, "Do you think it is a kind of a huge waste of money because every different individual's DNA sequence will be different?" And now they are pouring billions of dollars, the taxpayers' money on this. And what are you going to do with now by the time when it comes to actually reading one individual's DNA genome sequence? And then are you going to spend another such $1 billion on everyone's? I don't know answer, of course. And maybe I was leaning. At the time, I was leaning onto his side of the opinion. Yeah, that's maybe it's just too much crazy idea. Now, look at it in the year 2000. That was the first time ever the one particular individual genome sequencing was completed. It didn't really take too long. So that lucky individual was James Watson, because that was the probably he was at the time the head of that the institute who oversaw the project. James Watson, who the person who for the first time revealed the DNA actual structure of the DNA double helical structure and won the Nobel Prize. Yeah. So this is the data following the drop in the cost of sequencing the human genome. So already immediately after the completion of genome project, it became 300 million, and then in the year 2010, like around only 5,000. It's been said if the cost was only about 5,000, many people in the world can afford actually allowing their genes to be read. 5,000, hey, I have money. Now even it's the year 2012, even only 1,000, even only 100만 won. Wow. And then last year it was only about $300. Perhaps many of you listening to my gibberish lecture even could afford $300 to read your genome. Yeah. In the 2020, the projected $20 is too much. Yes, it's we didn't we are not there yet. However, so it will come sooner, much sooner than later, that the days of being able to finish your genome sequencing with the money like only about $20 or so. That means everyone easily. This is such an affordable process. Not only the cost, but the time also is. Even in these days, completing the entire DNA sequencing is only, it takes a couple of weeks actually, and then it will be reduced further. So then, in a matter of several days, just like completing the COVID PCR test, like within a day, probably you will be able to finish the reading your entire genome. Yeah, I can assure the day will come soon. So it can become such a routine in your everyday life. What's the impact of such accessible, affordable genome sequencing? That will enable the new way of medicine, so-called customized medicine. So if you can read your whole genome, then you can predict what type of, in percentage, you can predict the probability of having you as an individual having that particular disease. Like next 10 years, probably the chance of you having the breast cancer is such percentage, stuff like that. Then you can prepare for that. Up until now, all the way, the cure, the way you can handle any particular illness is only if you are lucky enough so that already the method, the cure is available. So that we call that as a standardized medicine. It has to be already ready on the shelf so that you can choose. If any cure has not been developed, then sorry to say, but unfortunately you cannot be treated. It's the downside of this standardized medicine. And also, it is only reactive. Only you can take action only after you recognize that you had this particular illness. Now these two, then you can move the entire trends of this, the way handle this disease, into this new personalized. So it doesn't matter already standardized method of the treating is not available, but we can develop. This is what is called the personalized medicine, because your genome is unique, so then we can come up with your own unique way of handling such particular the illness, and also preventive. You can anticipate and then do something in advance. So it's been already on the horizon. It's there, waiting. So the first part of this technology, which is about genome editing technology, the genome sequencing technology, now can recognize and can anticipate, identify the problem, and also anticipate the problem. However, still you cannot do something about it if there isn't any already cure exist. The fix now can be provided by this another type of new technical breakthrough called the genome editing techniques. So these genome editing techniques, basically the bottom line is you can manipulate your DNA sequence very easily. So previously already we've been already having this similar, maybe you can consider that the technique is a similar technique like GMO, which most of you have not a pleasant opinion about this GMO issue. Obviously, as one of the molecular biologists, I don't really have. I am a strong proponent of this GMO, and maybe later I hope we have a little time spared for the discussion of the pros and cons of this GMO technology. But This GMO technology is like apple and orange between GMO and the genome editing. GMO here is usually basically you are trying to implant whole the genes from the outside of a source into the target organism. And usually what you can achieve is in this GMO, you can manipulate that particular genes, the gene expression level. And another thing is, if that target cell already have the native gene, you cannot silence that native gene's influence, but simply you can have only additive effect. Maybe that is not entirely true, but okay, just bear with me. So the issue is you still have some of this your native gene influence issue, which is not easily dealt. However, in the case of this genome editing, it's like really you are able to edit the gene just like you are editing in your reports in the word processor file. When you don't like any particular expression, then you can entirely change into something a new different way of so like just like that you can change the particular sequence of DNA on your gene into something that you want, is what the genome editing technique can offer. So actually this genome editing technique is just like almost all the new the gadgets of molecular biology. It was something that borrowed from bacteria. That's one of the reasons why we should not neglect any other living organism. We always learn and take something from others. Okay? So this the whole core mechanism was there in bacteria, being used against virus infections, and then somehow accidentally discovered them, and then some scientists start using in fixing, in changing the other organisms' DNA sequences. It's pronounced as a CRISPR. Usually Cas9 is one of such a core enzyme involved in. So CRISPR-Cas9 system is the core of this genome editing technique, the most commonly used core of this genome editing. And maybe it's useless to show this diagram of how this enzyme works under this CRISPR-Cas9 system. Is the bottom line over here is, hey, if you have particular target DNA sequence and this genome editing CRISPR system can particularly target that area, and if you don't want to change, you can even create a mutation, or even you can change that particular sequence into something different. So like, yeah, there's no limit of the degree of the alteration in that particular region is what all is about. So yeah, that's why I can compare this as just like a biological version of this word processor, and find and replace. There is a command in our word processor program. Yeah. So can this genome editing CRISPR system do. So can delete and add and modify whatever you want. So if those diseases, most of diseases actually come from the DNA differences, some mutation, and a lot of them, okay, almost all of them. So if this is a matter of finding what particular disease and what particular trait is linked with that particular gene, and how is the relationship. This is just a matter of like, so we has a still so much long way to go until actual 100% full-fledged power usage of this genome editing techniques, because our knowledge, understanding level of this whole gene function is still at the very infancy. But assuming that that level is making huge progress in a very near future, and with this powerful genome editing technique, and there's almost nothing impossible in changing, manipulating your genome. Is a very scary thing, actually. So now the whole paradigm of the evolution is now on the way of mending, in that up until now evolution is what? You have already existing variation, right? And only existing on the existing variation can the Mother Nature, in the form of, under the disguise of different environments, and have some specific individual impact. And throughout that procedure, adaptation, the reaction, adaptation reaction, then now the procedure that we call evolution occurs. That has been the way for several billion years from the beginning of life on Earth. But now, if you think about it, the new prospect, traits, what traits? The variation you can create. You don't really have to wait and see games until actual desirable variation occur in your population. You can actually actively create a new variation through this genome editing. Wow, what a scary things. Actually, those things that's been extensively applied in almost all other human interest related species, including different plant crops and livestock, and within 5 years, like in past 5 years, that's been such an the boom in molecular biology. Only the human, until now, this all the scientists involved, this had some kind of a agreement and pledge that we will never touch on human embryo in this new technology. Because, however, maybe some of you might have heard the news from China some time ago, like 1 year ago, about one crazy scientist even actually attempted this CRISPR technology on an infant, in human embryo, to fix some fatal disease. And although that particular scientist has been all banned from any further scientific activity from then on, but I think personally it's just a matter of time that they will start having hands on this human with this technology. So in other words, you will have this creating a new variation in human, so new species and environment even. Here, although we are actually having the negative side of the impact on the environment, but we already know that human activity can have such a great impact on the environment. Look at the recent really doomsday issue of climate change. Look what human can do. So this environment and variation issues no longer as any kind of playing any as a limiting factor in creating new evolution. So in other words, if we are living in a very near future, if are living in the years of the days of we can easily manipulate our genes and create new traits. What kind of traits, what individually speaking, what everyone would carry a specific trait? Would it be interesting to ponder about? Is my final comment about this particular chapter. So, with that, I hope everyone has the wonderful 4-day weekends, and then see you soon.